Hello, my fellow gnomes, and welcome back to another video of Doors. Now, at the moment, we've got a pretty good gameplay environment going on, and we've got plenty of furniture to interact with. But it's not really a game, is it? Just crawling in and out of cupboards. So instead, we're going to add a monster today. But before we do that, we need a better way to interact with our game, because at the moment, if we go into my server script service into a server script, we just generate a bunch of rooms and then that's it. We're not really reacting to the game environment. We don't know which room the players are in, for instance. So let's go ahead and we're going to use a bindable event. We're going to pop this into the room and we're going to add in a new bindable event. You might notice all the icons have changed. They look a little bit different. Can be a bit confusing, but hopefully we can keep track of things. So we're going to name this bindable event player enter. Okay, and we're going to fire this whenever a player moves through a door, whenever they open a door, so we can know where they are. So inside of our door module, we can create a variable for that. Local player enter equals script dot parent dot player enter. And then whenever they open the door, we're going to fire that event. So player enter, and we say fire. Now we actually want to send a bit of data as well. I want to send not just the model that we've opened, but the actual number as well. So what we're going to do is we've already got the number inside door.new function. So copy this number and make sure we send it whenever we call this function. So here and here, we'll send the door model and the number. There we go. And then now we can make sure we are expecting the number. And then when we fire, we will send the number. And then inside of our main server script, we generate all these rooms, but we're not keeping track of where they are in relation to each other. So we're going to create a new table called local generated rooms, which is just going to be a blank table initially. Well, in fact, we could put the previous room as the first value. Okay, so that start room is going to be the first value. But then after that, we're going to add, every time we loop through this, we'll say generated rooms I. The value of I, of course, is going to be 2 initially, then 3 and 4 and 5 all the way to 100. And we're going to set that equal to whatever the new value of previous room is. And so once we've gone through and generated everything, we should have a nice little table, which will show us the order of all the rooms. So if we just do that and we click run, we should get in the output. Let's see, we have a table. And if I open this up, we can see we have a nice long table, 100 long. Starts off with the start room, then left snake, upstairs, left turn, and so on, which is the exact order everything is in. Left snake, upstairs, and left turn, and so on and so on. So now we have this nice little table. Let's make sure we're actually receiving when a player enters a door now. So we fired off that event. Let's receive it here on the server script. So we'll create another variable, local player enter equals script.room.player enter. And then down here at the bottom, we can say player enter dot event. So when that event is fired, we're going to connect that to a function, and we'll take the number as a parameter. And now we can make things happen when the player starts to go through certain doors. So for example, we could say if number equals 3, then let's just say workspace clear all children. Okay, so we're going to delete everything, but just as a quick little test. So if I was to click play now, we can load in and join the game. There we go. So we go through the first door, no problem. 1, 2, and when we go through the third door, things aren't going to go very well for us. We go through here, and oh gosh, everything has been deleted, and it's going to cause a few glitches because the game doesn't really like us trying to destroy everything, such as the terrain, and it breaks our character a little bit. We would have to reset, I think, to get that to work. maybe. It's all broken. But anyway, we can see that it's working on door number 3. But we don't want to just delete everything. Instead, we want to spawn in a monster. So let's go ahead and create our monster. So to do this, I'm going to actually take a copy of these door templates. So we see we've got one here, entrance. I'm going to copy that, move it into the workspace, and just move it out of the way. Okay. So I'm going to rename, let's rename it from entrance to skull. And then on this side of it, I want to add in a image. So I'm already got an image. I'm just going to paste that on top. There we go. We've got a spooky skull. And then I'm going to want some sort of smoky particles around him as well. So I'm going to duplicate the skull. And then I'm going to resize him. Okay. And I want this wide part to be as wide as the widest corridor. So obviously these aren't that wide, but I have got this gallery, which is really wide. So I think I need it to be probably 50 studs or so wide. So we'll make it really wide like that. Perfect. We'll rename it from skull just to smoke. And then we're going to unanchor this part, unanchor the smoke. We can delete the decal, and then I'll add in some particle effects. So use a particle emitter, and then we can have some lovely little twinkly effects. It's not going to have quite the bone-chilling effect we're looking for, but I have already made some effects. So I'm going to delete this, and then I'm going to paste in my new effects, much better. And let's make sure both of these parts are fully transparent. There we go. And I think we have something that looks a little bit more spooky. So let's take the skull and we'll click the smoke and we're going to weld these together. So we'll create a weld between them both. There we go. We can see that weld constraint has appeared. And then we're going to select them both and Control-G, group them together. We'll call this guy skull or shadow or something. Shadow, I guess that works. And then we'll create a new folder to put them inside. We'll keep everything organized. Since we've already got furniture, item, and a room folder, we'll create a enemy folder and we'll drag this guy inside of there. There we go. And then we're going to create a new module script specially for him. So we'll add a new module script into the server and we'll call it shadow. We could obviously call this whatever we like. It's called Rush in the actual Doors game, but we'll go with Shadow just to be a bit different. So we'll rename it to Shadow, and then we'll have a function shadow.new. And what we're going to expect for this is we're going to need a place to spawn him into the world. And to do that, we're going to use that very table that we just created, right? That generated rooms table. So we're going to want the number that we're currently at and the total table of everything, generated rooms. So we'll start by making a copy of him. So local enemy model equals workspace dot enemy, that folder we just created. Maybe it should be enemies. Just it seems we've got everything else to be plural. Sure, we'll do enemies. There we go. Workspace dot enemies dot shadow, and we'll create a clone, a copy of him. And then what we want to do is when a player moves through any of these doors, we don't want to spawn the monster immediately at that very door that they've just walked through. Otherwise, they're going to get killed rather quickly. Instead, we want to generate them a room or two behind and then have them move through the world, maybe an extra room in front as well. So the first thing we're going to do is work out what the previous number is. So the previous room number is simply going to be whatever the number we've been given, that minus 1. Pretty straightforward. And then local max num, that will be, let's just make these num, is going to be however far forward we want to go. in this case, maybe we'll just do it an extra 1 room, okay? And so then we can work out these values. So the maximum room and the previous room itself. So the room model, the previous room model, is going to be equal to the generated rooms table. And then we'll just use that previous num value. And then we need to work out the maximum room. Now, we can't simply do this because it's possible, say, if we were on the 99th room, we could actually go one too far. So let's just check. If not generated rooms max num, if for some reason it doesn't exist, then we can say that the max num will simply equal however many items there are in the table. So hashtag generated rooms. And so now we know that the local, the max room is simply equal to generated rooms max number. Okay, so then what we want to do is we want to place that enemy into the position of the previous room. So we can say enemy model, and we use the pivot to function, and the position is the previous room dot the entrance part dot cframe. And then let's make sure to give him a parent. So enemy model dot parent, and we'll place him directly into the workspace. So that's our shadow module script done. Then in our server script, we're going to need to require that. So where we've got all these other modules, we can say local shadow equals require script dot shadow. And then inside our player enter event, if they enter door number 3, then shadow.new, we give them the current number and the table of all the rooms. And we don't need to print them out anymore, so we can remove that line. Okay, let's hit play, and we can see if this has worked for us. So we can move into room 1. Oh, look, we've got the gallery straight away. Wow, what are the chances? And if we move into room 2 and then room number 3, and if we look behind us, we should now see there he is. It is the spooky skull himself. So he spawned 2 rooms back. Well, 1 room back, but of course, because of how it works, he's gone 2 rooms back right to the start room door. There he is. So, that's the generating of him, but now we want to have him move through the levels. It's not really enough to just have him looking ominously through the door, is it? So if we hit stop, what we're going to want to do is we're going to want to move him, and how we're going to do that is we're going to use something called lerp. But before we do that, we're going to need some sort of waypoints to move through the world with. Now, obviously, if it's a straight room like the gallery or any of these corridors, well, we can simply tell him to move from the entrance part all the way to the exit part. It's a straight line. That's pretty straightforward. But if we've got one of these, say a corner especially, but also those stairs, if it's a corner, well, we can't just tell him to go from this one to this one because he'll travel in a straight line like that, and it'll cut off the corner, and it will just look terrible, frankly. So what we're going to do, you'll see I've actually already created some little waypoints here myself. What we're going to do is we'll take the entrance part and we're going to duplicate it like so, move it forwards to just before the turn, so like here, and then we're going to name it 1, and we'll make it fully transparent. And then we duplicate it again, move it forwards, rotate it, rotate it 90 degrees, and then we'll move it round to the next corner. There we go. Make sure it's all lined up in the center. And then we'll name this one 2. Then we'd move it forwards again, right before the next corner. We would name this one 3. Duplicate it one more time. Rotate it again, move it right round the corner, make sure it's lined up. Is that lined up? Oh, we need a half stud to the left. Like so. There we go. It's lined up now with the exit. And then we name this one 4. And so once you've got all of these waypoints, you could select them all like so. 1, 2, 3, and 4. Add them into a folder and name them waypoints, which you see I've actually already done. I already had another set here. So now I've got 2 sets. I'll delete one of these. But there you go. So we've got our waypoints. And we need to have this for every single room. So every time you've got a corner like that, you're going to need to create some waypoints. You see I've got some here. There we go, exactly the same for the other corner. And I've got some for the my little snaky one as well. If I can find it, there we go. Some more waypoints here. We've just got 2 waypoints here, it's just one corner. But for the long corridor, say, for example, I haven't actually got any waypoints at all, just the entrance and exit. So you only need to add the waypoints if you've got a corner. I did go ahead and add some for the staircase as well. You'll see I've got a waypoint here, one at the start of the staircase and one at the bottom. And just as with the entrance and exit parts, it's really important that you have the orientation indicator correct. So I have all of mine facing this way. So we can see when we look at these waypoint parts, they're all facing exactly the same way as the door. So everything lines up all the time. If you swap the orientation indicator around, then it's going to cause some problems for our enemy moving through them. But once you've hopefully gone and created all of your waypoints, we can now go and start programming that. So let's head back into our shadow module script. And we're going to create a new function called shadow.navigate. And so we're going to need the model to move. And then we're going to have the previous num and the max num. So these start and end rooms to move through. And we'll need that table of generated rooms again. And so we're going to have a for loop. So for I equals previous num and finishing at max num do, and then we can get the room. So the local room is simply going to be equal to generated rooms I, and then we can tell him to move to any of these rooms. So like I say, we're not using a humanoid here, so we can't say humanoid move to or anything like that. We're going to use lerp. So we'll create our function for that. Function shadow.lerp2. And this is going to simply have the model and the target we want to move towards. Now, if you're not very familiar with lerping, I'm probably going to make another standalone video on this at some point. But lerping is essentially about interpolating between different values. So if we have one value A that's equal to 1 and one value B that's equal to 10, and you wanted to create a value C that was halfway between them both, well, that would be 5, wouldn't it? That would be 50% of the way. Now, in our case, you want to keep generating whatever fraction of the way we want to move inside a really fast moving loop to allow him to move smoothly through. Now, this fraction is known as alpha. So we set the alpha initially equal to 0. Then we're going to set a speed that we want him to move at. I'm going to set this to 50. And then we're going to say that the local distance is equal to the model.primary part.position minus that target.position. And then we're going to get the magnitude of this. So the total distance, right, dot magnitude. And then from this, we can calculate a relative speed. So the relative speed is going to take into account the distance. So that's simply equal to distance over speed. And now we're going to need to actually keep track of his starting position. Because if we're moving him, then we need to know where he started off at. So his start cFrame will be equal to the model.primary part.cFrame, and then we'll create our loop. So local loop will be nil initially, and then we'll set the loop to, rather than just using a for loop, we're going to use something called run service. So run service allows us to tie things on a frame by frame basis, so we can have a really fast running loop. So get service, run service, and then we'll say loop equals run service dot heartbeat, so we can see it fires every frame after the physics simulation has completed. So whenever the heartbeat fires, we're going to connect that into a function, which gives us a really tight running loop. And we can see one of the parameters is something called delta. Now, delta tells us the amount of time difference between each frame, which is going to be very useful. So the first thing we want to do is we want to work out how far we want to move. So local goal cFrame is going to be equal to we take the start cFrame, and then we're going to lerp. And we want to lerp between the two values there's two values. The first value is the start cFrame, and the second value is our target, which we have as a parameter for the function itself. And then the second thing we need to say is the fraction of the distance we want to move. Now, in this case, it's going to be alpha. Now, initially, that's 0, which is fine. On the first frame, we want it to be at the 0 position. And so we'll say model pivot to, and we'll pivot it towards that goal cFrame. But after we've done that, we need to calculate what the next value of alpha is going to be. So alpha plus equals, so we want to add to it, and that's going to be that delta value. Okay, so that's how long since the last frame. It's normally about 0.1 of a second. So that divided by that relative speed value. And then finally, we want to say if alpha is greater than or equal to 1, then in that case, we have finished the loop. So we can say loop disconnect. Oh, there we go, disconnect. Now, this was going to move us to only a single position, and we want to move to multiple positions. So that's why I created this for loop down here in the navigate function. So what we're going to do now is we can call that lerp2 function. So shadow.lerp2. We want to go from the model, and we want to move it to the room.entrance. And then we're going to need to see if it has any waypoints, any of those waypoints that we just created in those folders. So let's check if it has a waypoints folder. Local waypoints equals room, and we'll use the find first child function and look for something called waypoints. Now, if it does have waypoints, then we're going to want to loop through them. So we'll create yet another loop for I equals 1 and the number of waypoints. So that's hashtag. Hashtag gives you the amount of items in a table, and that table is going to be all of the children elements of the waypoints folder. And so what we're going to do is we're just going to use that lerp2 function again, and we're going to lerp to each of those waypoints. So we send the model, and we want to move to waypoints and the I value of the table, which we're getting from the loop. Now, there's one problem with this so far, which is that when we are running this, well, we haven't added any sort of weights. We haven't added a task.wait to pause in between. We're just sort of doing everything all at once. And how could we know when this loop has finished, when we've disconnected? Well, one way of doing this is to use yet another bindable event. So I'm going to go down here and I'm going to say local reached target and make that equal to a new bindable event. And so now when we disconnect from the loop, I can fire off that event. fire. And at the end of the function, I can say reach target dot event, and I can wait for that event to fire before we actually return the function, before we finish it. So it's going to keep yielding. It's going to keep waiting here until this loop is finished. So that will add in a wait, and it can be dynamic rather than having a set time that we actually type in. So once we've done that, and once we've finished moving through all of these, we need to move to the exit. So shadow loop to model room dot exit. There we go. And then this is going to keep repeating through each of the rooms you want to move it towards. So we set it to -1 and +1, but obviously we could change these values if we wanted. But once we've done all of that, we're just going to destroy the model. So enemy model. Oh, we haven't even called the function, look, have we? So we're going to want to call that function. So shadow dot navigate, and we're going to need to send the enemy model, the previous number, the max number, and the generated rooms. And then we know that once it's done, we can safely destroy that model. So that's a lot of scripting. Hopefully you've stayed with me. But now let's go ahead and play. See if we got any errors. Make sure our output window is open. We'll hit play for ourselves. Let's see if we go through the third room. And oh, we have got an error, look. Attempt to index nil with position. So what's going on there? Let's hit stop. And we go and look at line number 7. So I'm guessing there's probably an issue with our target. Let's just check. So when we're calling the loop to room.entrance, waypoints I, room.exit, that looks okay. Has our model got a primary part? Let's check. It hasn't got a primary part. So let's click the shadow primary part, and we'll set it to the skull. Okay, so now we've got a primary part. Things should be looking up. We'll clear this output. We'll click play. And then we'll come around the corner into the third room. And we've got another error. So we have to go back and we'll check on line number 14. We're unable to cast instance to coordinate frame. And we just forgot to set the C frame there, didn't we? So target dot C frame, because target is just the instance. Right, let's try one more time, guys. There we go. 1 and 2 and number 3. There we go. And if we see, whoop, there's the the little monster there. He's flying ahead of us, and we've got another error here. Attempt to call missing method destroy of table. So we've messed that up too as well, it seems. What have we done here inside of our shadow script? Oh, we've called shadow destroy rather than the enemy model, which is what we wanted to destroy. And how about we have this, instead of it just coming on room number 3, we could have it say every 4th room, for example. So if we wanted to do that, what we'd need to do is we can use the little percentage sign, and the percentage sign tells us like a division. So we're going to divide by it, and we're going to find out what the remainder of it is. Now, if the remainder of it equals 0, then it divides exactly by 4. So we know it's 4 or 8 or 16 or some combination of 4. So if we hit play again, 2, 3, and 4. Let's run back so we can see there he is, speeding ahead. We're going to need another key here. And if we get to room number 8, where is he? Let's have a look for him. And there he is, coming along, speeding ahead again. And we'll go to room number 12. We're going to need another key, look. Where's that darn key? There it is. And we'll see him. And here he is. And down the corridor he goes, navigating through all those waypoints. So that all seems to be working perfectly. But it's not really very spooky, is it? We're going to want some sound effects. We're going to want Maybe some flickering of the lights would be nice. And also a way to actually kill the players so that they have to hide in these closets. So let's work on all of that next. Okay, so let's start off with the fun thing, which is killing people. So let's jump back into our shadow module script. And I'm going to create a new function at the top. And I'm going to call this function shadow.find players. So we need to find players and then we're going to kill them. So we'll call this function from within our moving loop. So whenever we're moving along inside of our little run service loop here, the first thing we're going to do is we're going to try and look for some players. Now we only want to find players relative to the position of the model. So let's send the model as a parameter, and we'll make sure we include it here and the function. And then all we're going to need to do is first off, we're going to get all the players. So local players equals, and we're going to use the players service. So we'll create a variable for that. Local players equals game get service players. I'm just going to move these services lines up to the very top of the script. I just like to do that for organization. But back to line 7, local players equals players get players. So that's going to give us a table of all of the players. But we don't actually want their player object. We want the player's character. So that's their avatar in the world. So we're going to have another table called characters. Initially, this is going to be an empty table. But then we're going to loop through all the players. So for I player in iPairs players do, and we're going to check if they have a player dot character, then we'll add them into the table. So table dot insert into that characters table. We will add in the player dot character. So the next thing we want to do is we want to check which of these characters are within the hitbox of the shadow model. Now, a lot of the time I've used the touched event, but that's not very reliable when we're lerping it just by setting the C frame. But what we can use is one of the new methods from Roblox. So we're going to use the workspace get parts in part method. And so the part is simply going to be model.smoke. Okay, so that smoke was the name of that big long part we created. And then there's also another option of overlap parameters. So we can go ahead and we can create these. So we can say local overlap params equals overlap params.new. And then it's just a bit like setting up a raycast. So we set some different properties. We have the filter type equal to enum.filter. It's actually enum.raycast filter type. It uses the same enum as a normal raycast. We're going to use a whitelist, and then we're going to set the overlap params. Oh, make sure that's lowercase. Dot filter distance instances, and that's going to be that characters table that we just created. So we're only interested in checking these characters, nothing else. So then now we've got these collisions. Oh, make sure we add the overlap params as the second parameter. But once we've got those collisions, we can then loop through all of them. So we'll say for index object in iPairs, and it will simply be each of those collisions. And then we'll check if the object.name, if it's equal to the humanoid root part, and make sure we capitalize that H. If it is, then what we're going to do is we're going to raycast towards it. And we want to check if we can actually see it. Because if they're hiding in a cupboard, then we don't want to be able to kill them. We only want to kill them if we've got a clear vision on them. So let's create a little raycast for ourselves. So we need a raycast direction. So the ray direction will be the object.position, and then we take away the model.smoke skull.position. So when you take away one vector3 from another, you get a directional vector. And so we can use that now to construct our raycast result. So workspace raycast. First parameter is where we're going to start it off from. That's simply going to be the model.head. Sorry, not head, it's skull.position. And then the direction using the ray direction value. And so then we'll check if we have a result, because it's possible that the raycast could just hit nothing at all. But if we've got result and we have a result.instance, so it's actually hit a part, then we can actually just say local hit equals result.instance, just makes it a little bit easier to type. And then if that hit equals the object that was in the original collisions table, or hit find first ancestor object.parent.name. So in other words, maybe we've hit, say, the character's head or their foot, but we're going to check if that's inside of a model, if it's inside of an ancestor with the same name as the original object, right? So the head is obviously going to be inside of their character, so that'll then return true, and we can just print out hit to double check everything's working right. And seeing as that we know that the parent of the object is a character, because that's what's in our collisions, in our character table, and that's the only thing we're looking for in our collisions. Therefore, we could say object.parent.humanoid, and we could just set the health straight to 0. And for the purposes of testing, let's just reduce the speed way down. So we've got it as 50 at the moment. Let's just set it all the way down to 10. Okay, and now we can go ahead and test this new function that we've just created. Okay, into room 4, and we should now trigger the monster. And we should see the monster starting to move forwards. But as long as we keep out of reach of him, we should be fine. But if we don't move, we just let him turn and get us. We should. Oh no, we've died. We see 18 different hits were registered. So we could add a debounce in there if we wanted, but it doesn't really matter that we're going to have multiple collisions as it keeps moving for every frame through us. But seeing as we're just killing the player, that doesn't matter too much. But let's just test that again. This time, how about we could hide inside one of the areas and see if the raycasting is working correctly. So I'll bump up my speed again, and I'll head forward to the next room. Okay, we're now in room number 8. And if I look, there's the monster. And if I hide inside the cupboard, it should pass us by. There we go. It's kept moving. And the raycast, because it didn't hit us, we survived. And it keeps moving through. And it disappears as it enters the final door. Now, that's working, but it's not really very spooky, is it? So we're going to need some sounds. So we can add in a sound real easy. I'm going to go to the skull part, and I'm just going to paste in. I've got 2 sounds that I've already found. This one is called drone. It sounds like this. I think that'll do the job nicely. And then we've got a whoosh sound as well, which we'll use when he disappears at the end. So the drone sound we're going to want to play immediately when we spawn him in. So in the shadow.new function, just before we start the navigation, let's say enemy model dot skull dot drone, and we'll tell that to play. And then the whoosh sound, we want that to happen as soon as he is removed. So we could just type it down here before we destroy it. But there's actually a property of the sound we can click. So if we go to whoosh, and we find the play on remove property, and we just enable that, then it'll do it for us automatically. So we can click play, and we can see what that's going to sound like in game now. through room 4, and we can hear the evil demon in the background. There is the... shall we turn his speed back up a bit? We don't need him to be at 10 speed anymore. Let's send him back to 50. Or maybe even 60. Let's try him at 60. Okay, room number 4. And there he's coming, and oh, he's taking us out. That did not give us much time at all, did it? But I think that works a lot better. So now we've got the sound effects, but we need a little bit of warning so we can anticipate him. Now, how they do this in the actual Doors game is they make the lights flicker. And that's what we're going to do next to set the ambiance before we introduce the villain, as it were. So what we're going to need to do is we're going to need to make sure we've organized our models. Now, I've already kind of done this. So if I click on any of my room models, we can see I have a few folders such as furniture, walls, waypoints, and such now. But I also have one just for my lamps. And inside of the lamps folder, I have each of the lamp models. And if we look inside here, I have parts called shade, right? Which are these parts. These are called shades, so like the lampshade. And whenever I have a part called shade, I have a point light inside of it. So if I look inside any of my models here for the rooms, we see I have a lamps folder. And inside here, there's a bunch of lamps. And inside of it, there is 2 shades, both containing a point light. So I've done this for every single one of my rooms. Even including the gallery room, right? We can see I've got some lamps, and exactly the same, we've got a part called shade with a point light. So we've got this consistent across every single model. And so now we've got this structure, we can access this from our script. So let's go into our room module script, because that seems like the most logical place to put it. And we're going to create a new function room.blackout. Okay, and we're going to turn off all the lights. Now, the only parameter is the room model that we want to do it for. And then what we'll say is local lamps equals room model dot lamps, and we will get children. Now, every single one of my rooms has a lamps folder, so I can just assume it's there. But if some of your folder structure is different to mine, then this might need to be a little bit different for you. But if you've got a rooms just like the one I've just shown you, then this will work perfectly. So now we're going to loop through all of those lamps. So for lamp in, well, not map, lamp in iPairs, lamps do, and we then want to loop through the contents of the lamp model. So for object in iPairs lamp get children, and then we're going to loop through all of the objects. So we need to check if we find a shade object. So if object dot name, if that is equal to shade, then in that case we know it contains a point light. So we can say object dot point light dot enabled equals false. So we're going to this model, then we're looking for a shade part, finding the point light and setting enable to false. Now, since I've set these parts, the material to neon, that makes it really bright. So we're probably going to want to change the material type as well. So we'll say object dot material equals enum dot material, and I don't know, we'll just set this to glass, I think. And then we can call this room.blackout function from our main server script. So when we hit room number 4, then we'll say room.blackout, and that will be the generated rooms with the number. So square brackets number. And maybe we want to send the current room and also the next room to darkness as well, just in case they move through the rooms really quick. So we'll set both of them to black, and then maybe we'll wait Let's say we wait a second or two. So task.wait, we'll wait 2 seconds and then we'll spawn in the enemy. Let's see how that looks for us. Okay, let's enter into room 4. And oh, the lights have gone off. 2 seconds and here comes the enemy. Okay, that dealt with us pretty quickly. Now, just having the lights turned off in of itself doesn't really look that spooky. It'd be nicer if we had a bit of a flicker. So we could do that pretty easily using tween service. So let's do that. We'll go back into the room module and we're going to create a new function at the very top. And we'll say function room dot flicker light. Okay, and that'll have the light part as its parameter. So we can call this function from here, and we'll just send it the object, which is the light part. And then we're going to construct some tweens. So first of all, we're going to need tween service. Create a variable for that at the top of the script, as always for our services. So tween service equals game get service tween service. And then we can construct a tween. So we're going to want some tween info. Local info equals tween info.new. We want it to last, say, 0.2 of a second. enum.easing style. There's a few we could use, but I think elastic will work quite well to get a good flicker effect. enum.easing direction we'll set to in out, best of both worlds. Then the repeat count, we just want it to happen the once, and for reversing we'll set that to false. And then what I'm going to do is I'm going to create 2 different tweens. One tween for flick on, and that's going to be tween service create, and then that will be the light part dot the point light inside of it. And then we'll use that info, and we're going to set the brightness equal to 1 on the flick on tween. And then for the flick off tween, it's exactly the same. It's just be called flick off, and we'll set the brightness to 0. And then what we'll do is, first of all, we'll play the flick off tween. So we'll play that. We'll wait for it to finish. So flick off dot completed and wait. And then we'll set the material to glass, just like we did before. So light part dot material equals enum.material glass. We'll copy these 3 lines, paste them down below, but this time we're going to play the flick on tween. So we bring the lights back on for a short second, set that material back to neon, and then after that's done, we're going to finally turn them back off again. So this should have them flickering all on and off, all a bit more crazy. And now we've got this function, we can call it, we're calling it from down here on line 35, and we can remove these 2 lines. We probably want a little sound effect to go with it as well. Now we could place it directly inside one of these parts for some 3D sound, but I think I might just put it directly into the workspace for this one. So let's add in a folder called sounds, and I'm going to paste in the sound that I've already got. So I'll paste it in. It's called flicker. Sounds like this. A little sort of electric sound. And then we can play that from inside this function. Well, actually, no, let's play it from the server script. So just down here, we'll say workspace.sounds.flicker play. But inside of our Veeam script, instead of just calling this function, that means that each light is going to flicker one by one because we're waiting for all of it to finish. We're yielding the function before we finish off. So rather than do this, let's just add it inside a little task.spawn function, which will allow us to sort of open up a new thread. So this function can be running while we keep looping through, and we can keep running multiple functions at the same time. So let's hit play now and see how this works. It should hopefully be a bit more spooky. Okay, here we go. Into room 4. You ready? Ooh. Okay, the lights have flicked off. And I'm going to try and get through, but oh no, I've been killed. That was a bit unlucky, getting hit right there in the downstairs room. But there we go. I think that looks pretty spooky. Let's try and get into another room just so we can see what it looks like a bit further on as well. Again, we'll boost our walk speed up. There we go. Okay, room number 8. Ooh. Better get into a closet quick. Whoa, that was close. That was close indeed. One final thing we might want is maybe to have the final door open up as the monster goes through it. Because at present, the monster goes through the door, but then it's still locked. So let's do that really quickly. That's nice and easy. We've already got the door.open function, right? We already have this function that exists. We just need a way to open it from a different script. And how we're going to do that is we're going to use another bindable event. So inside of the door.new function, just below when we're using the touched event, let's create a bindable event. So local bindable equals instance.new bindable event, and we can say whenever this bindable is fired, so bindable.event, connect it into a function, and we'll check if the door is open, or rather if the door is shut. So if door model, and we use this get attribute open, right? We can copy this in fact from up there. So we're checking that the door is currently shut because we can't open a door twice, obviously. We'll destroy the lock just as we did before, and then we want the door to open. So we can just copy that as well. Copy that down below. And so this will open it whenever we fire this bindable. Make sure we set the bindable.name equal to something that makes sense. We can say open event, and then we want the bindable.parent to be equal to the door model. Then let's head back into our shadow monster. And where is it? Well, when we're navigating through, we've called the navigate function. And so we're finished moving. Then we just need to find the last door of the last room and then find that bindable event to fire. So the last room, well, that equals the max room here. We've already got that. And then so the last door, it will simply equal the max room dot door, and then we'll say last door dot open event, because that's what we named our bindable member, open event, and we'll simply say fire. And when we do that, we should have our door open as the monster disappears. 7 and 8. Right, so that door's locked. I'm going to hide in the cupboard. And we should see, as we look ahead, he has opened that final door for us. So he's actually helped us out. We didn't have to unlock that one. There we go. So we've got all of this wonderful stuff working. We've got a bit of a horror aspect to our game. And we've actually got a monster to avoid. Talking of which, whoa, let's get in the closet quick. Nice one. So we still have some more things I think we need to add. Let me know if you have some ideas in the comments. And until then, I'll see you all in the next video. Goodbye.